Demonstration of model-based supervisory control design. This small factory will be used to show the advantages of supervisory control synthesis. First, the plant model and the requirement model of the different machines are made. Those models can be used to synthesize the supervisor. Every machine has its own supervisory controller. Global requirements are added. A coordinator will be generated so the different machines will work together. The controllers will be simulated and examined. When the system meets the requirements, the PLC code will be generated to control the real-life system. But first, a plant model of the different machines will be made. This has been done in the programming tool SIF. The plant model represents the dynamical behavior of a single component and the relationship between different components. For example, here you see a cylinder with two sensors. When the cylinder is retracted, the left sensor is activated and the right sensor is deactivated. While the cylinder extends, the left sensor is deactivated first. When fully extended, the right sensor will be activated. This is the relationship between the sensors and the cylinder. Next, the requirements model has been made. These requirements determine how the system should work. The plant model and the requirement model are finished. Subsequently, the supervisor has been synthesized. The functioning of the supervisory controller will now be demonstrated in real life. Here you can see the different machines. This is the product dispenser, the stamping machine, the handling device, and the product outfeed. Every machine can work separately. The stamping machine puts a stamp on the product when this is added. The product dispenser dispenses a product when activated. This process continues until the dispenser is empty. When activated, the handling device will start moving products. When the gripper is not in the upper position, the supervisor will prevent that the gripper moves in the vertical direction. Now coordinator has been added so the different machines work together. Before the controller will be tested on the system, the controller is simulated. This way problems can be detected in the designing phase to reduce errors after the system is built. So the development of a system and its controller is faster and cheaper. But there is a problem. There is a blocking situation. The gripper cannot drop its products. The supervisor of the different machines worked correctly. Only the coordinator did not automatically prevent this blocking situation. Therefore an extra requirement is added. Now the controller will prevent the blocking from happening. This system works as required. Now PLC code has been generated and the controller is examined in real life. The product dispenser is activated with a start button and the stamping machine with the key switch. The system works as required. There is no blocking situation. The system will continue on until the last product is processed. Now the system is empty. reset LED is turned on. After filling the tube, the system can be reset and started again. To complicate the system, a second stamping machine is added. In this setup, the stamping and the distribution machine needs to be approached from the right hand side. Models are added and the supervisor for the second stamping machine has been generated. Global requirements are added, a new controller has been generated and the system is simulated. As you can see, the system is not efficient. The first product is dropped in the last machine. With the coordinator, it's very easy to add requirements. That removes the inefficiency. Now the system works efficient. PLC code of the new controller has been generated, and the controller is tested in real life. Again, the system works as required. When the emergency button is pressed, the system freezes. Now the system is being influenced by external factors. After the emergency stop, the system will be re-analyzed. After starting, the production line will work as required again. With the supervisory control, it's very easy to implement a stop like this. Conclusion: advantages of supervisory control synthesis. If the plant model and the requirement model are correct, the supervisor will assure that the system correctly performs its function and meets the system requirements. With model-based engineering techniques, errors can already be found and fixed in the engineering process phase, where fixing problems is the most simple and cheap. The controlled system is non-blocking. It is possible to reach all marked states from all reachable states in the controlled system. The controlled system is maximally permissive. The system is controlled in such a way that it can react to every situation in a safe, controllable and non-blocking way. Supervisory control synthesis supports availability. Small changes can be implemented quickly and easily.